Alright, hello students, welcome you all once again to my small YouTube channel. So from today we are going to start a completely brand new series where we are going to learn some amazing shortcut tricks from alternating current. See, this chapter is also important. Why? Because each year at least one question they will be asking you in your NEET or JEE. See, one question carries how many marks? 4 marks, and 4 marks are not less marks. Why? Because even with the single marks, even with 1 marks, you will be facing a huge variation in the ranking, right? Even with the 1 marks counts a lot. Therefore, single mark is also very important for us. Therefore, this chapter is also a very significant in our preparation. Therefore, can we start the video? Okay, let's start the video. Yes. A simple reminder, if you like this video, don't forget to hit the like button, share with your friends, and yes, please subscribe this small YouTube channel. Okay, now the first problem. See, this problem has come from NEET 2016, maybe phase 2, right? Phase 2. The potential difference across the resistance, capacitance and inductance are 80 volts, 40 volts and 100 volts in an LCR circuit. The power factor of the circuit. Now we have to find the power factor. What we have to find? The power factor. Now observe, they have given resistance 80 volts. Okay, now we have to identify whether it is an inductive or capacitive circuit. First of all, see what is the capacitance and inductance they have given. Capacitance is 40, inductance is 100. So among the 40 and 100, which is largest? Obviously 100, right? So it is inductive circuit. Now we have a general method. You might be knowing it. If I go on solving with the regular method, maybe it might take half page. Really, from here it might take till here. Okay, because the solution itself is very long. Therefore, instead of solution, I'll be telling you a shortcut trick. If you find it comfortable, I'm definitely sure you will find it comfortable. Okay, you can use that shortcut trick. Within 20 or 30 seconds, you can easily finish this question. Nothing is there in this. As we know, what we concluded, it is an inductive circuit. Now, what will be the graph? How the graph will look like for inductive circuit? For inductive circuit, only we will be having positive y-axis. This is a positive y-axis. This is x-axis. Now, here. I'll start from x-axis. In x-axis, what we'll be having? Resistance. Resistance is how much? 80 volts. Now here what we'll be having in positive y-axis, we will be having inductance, LC minus LR, something like that we will write, right? So LC minus LX, LR minus LX, we will write all those things here. So it will be 100 minus 40. 100 minus 40 will be how much? Tell me. 100 minus 40 will be 60. Understood what I did? Okay. Now let us draw the resultant. Always we will be drawing the resultant, right? So resultant is very important. Now we will join this. As soon as we join, what can we conclude? See, if from here to here, if it is 60, then parallel to it, this line will also be 60. Okay, I'm sure, right? This line will also be 60. Now what is Pythagorean theorem? What does Pythagoras theorem says? If this is a right angle triangle, this is a right angle triangle, this is 80, this is 60, then this will be your 60 square plus 80 square. Can you see what I have written here? 60 square. This is 60 square plus 80 square. I will draw the diagram a little bit neatly here. Okay, this is the resultant. This will be your 80, this is 60, and this will be root of 60 square plus 80 square will be 100 volts. Right, so this angle is somewhat like, this is your power factor. This is your power factor phi. So power factor can be denoted by, how can we denote power factor? So cos phi. What is cos? Adjacent by hypotenuse. Adjacent by hypotenuse. What is adjacent? 80. Adjacent is 80. Hypotenuse 100. So if we cancel, what will be your answer? 0.8. See, in just one line, we solved the question that is asked in NEET 2016. Okay, this has a lot of significance. All the previous year questions I always see in my all videos. Okay, previous year questions are like the backbones in our preparation. They are very important. Why? Because they give us an idea like how the examiner will set the questions, right? So, previous year questions are very important. Everyone must revise previous year questions. So, the previous year questions itself I have solved in just one line. Cos cos phi, we just have to find what is cos adjacent by hypotenuse. Adjacent is 80, hypotenuse is 100. You got your answer 0.8, option number C. That's all. So simple, right? So similarly we can solve many problems based on this model. Easily we can solve. Nothing is there in this, just a small concept and a bit practice. That's all. Now let us move to problem number 2. See, this is also asked in AIPMT 2006. Okay, before introduction of NEET was called as AIPMT. You might be knowing all those things. Now, a coil of inductive resistance 31 ohm has a resistance of 8 ohm placed in series, okay, with a condenser of capacitive reactance 25 ohm. The combination is connected to an AC source of 110 volt. Okay, the power factor of the circuit. See, again you have to calculate power factor. See, especially in the alternating current, the problems related to power factor are very important. See, problems related to power factor are very important. Again, what to do? First, see, draw the diagram here. If you draw the diagram, this will be reactance. So this will be resistance. I'm sorry, this will be resistance. So resistance, how much they have given? 8. So 8 ohm I will write here. Now again, what to do? We have to calculate. You have to subtract this. So 31 minus 25. 31 minus 25, how much? 6, right? So write 6 here. Now if we take the resultant, then as from 0 to somewhat this point, if it is 6 ohm, then this will also be 6 ohm. Then easily we can calculate again Pythagoras theorem, right? This will be root of 8 square plus 6 square. Similarly, what I did in the previous problem, we can approach this problem also in the same method. Okay, this is 8 as I have already given. Then this we will calculate LC minus LR or LX minus LC. They will calculate, no? So similarly like that, 31 minus 25. Inductive resistance and capacitive resistance. We have to subtract it, right? Inductive resistance and capacitive resistance, if we subtract, we will get 6 ohm. So the resultant, again I will draw a better diagram here. Now this will be 8 ohm, this will be 8 ohm, this will be 6 ohm. Then the resultant of 8 square plus 6 square whole root is 10. This all things are basic. Now we need this phi. Why? We need power factor, right? We need power factor. How power factor will be denoted? Cos phi. So cos phi is adjacent by hypotenuse. Adjacent is 8. Hypotenuse is 10. So what will be your answer? 0.8. See, similar answer we got. So the power factor of the circuit is 0.8. That's all. 0.8. Very simple. See, in one line you got your answer. Nothing is there. See, if you go on solving this with the regular method, okay, you are welcome, but definitely it will take your time. But if you solve with this method, just by seeing at the question itself, you can easily guess. Why? Because we just have to keep in mind the Pythagoras theorem. If we grasp the Pythagoras theorem properly, then maximum questions from alternating current can easily be solved. Okay, now let us move to question number 3 or trick number 3. See, now question number 3 is somewhat like, okay, I'll solve on this paper. Now you can see the question here. See the question. A long solenoid of diameter 0.1 meter has 2 into 10 power 4 turns per meter. At the center of a solenoid, a coil of 100 turns and radius of 0.01 meter. Somewhat a long question. See, the question itself is so long, right? Question itself is so long. But if you go on solving the answer with the regular method, as usual, it will take time and lots of formulas, many formulas, you know, it's little bit hectic. Right, now I'll be teaching you a very simple and amazing shortcut trick. What to do for this type of questions. See, I have a special shortcut trick for you. I'll give you a shortcut number. Okay, Q is equal to, this is what you have to find, right? Remember my shortcut number. My shortcut number is 4 pi square. Remember this. Whenever you come across the questions based on this model, just remember my shortcut trick, shortcut number. Q is equal to 4 pi square. Now we have to divide with the resistance number. See, in the resistance what they have given, 10 pi square ohm they have given in the resistance. See, at the large they have given 10 pi ohm. So leaving the number, okay, what in the resistance, whatever be the number, leave that and write the remaining one, 10 pi square. So write that pi square here. If we have nothing, if we don't have any unit, then write 1. Okay, if we don't have anything, write 1 here. Now as we had 10 pi square, so leaving 10 pi square I have written here. Now we have to multiply some numbers. What we have to multiply? We have to multiply the current. What the current they have given? 4 ampere they have given. Am I right? 4 ampere they have given. Remaining nothing we have to see. As the question is long, you might see the question is so long, we have so many quantities, so many numbers. No need, just focus on what I am telling. Focus on the resistance. On resistance, just write the remaining part of number, then multiply with the current. How much the current they have given? 4 ampere. Then another thing we have to multiply. They have given that it has number of turns. How many number of turns it has? 2 into 10 power 4. That 10 power 4 notations all we don't need. Okay, because we are calculating with a shortcut trick, right? Who will take that notations, and it's a lot of headache, right? So instead of that notations, just take that number. What is that number? 2 into 10 power 4, right? So just take 2. Very simple, no need to panic. Okay, write my shortcut number first, then write the resistance value, multiply with the current and number of turns. Just 3 steps you have to keep in mind. Write this shortcut number, Q is equal to 4 pi square, divide by resistance number into current and number of turns. That's all. Okay, that's all, nothing else. Now you can cancel this pi square, then finally your answer will be 32 microcoulomb. That's all. See, in 2 lines you got your answer. Very simple. Okay, it's alternating currents is one of the most easiest chapter in physics. Okay, just with a small concept and practice easily can be solved. Now let us move to question number 4 or trick number 4. So the next problem is also a previous year based question. Okay, the problem is, which of the following combination should be selected for better tuning of an LCR circuit used for communication? See, for communication we always use some LCR circuit. Like for example in radios, like we have resonating frequency. At a particular frequency itself we will be having a nice sound, or else we will be having some blur sound, right? You might have heard if you had experienced a tape record or radio, right? So we always have to use a particular tuning frequency in order to get the smooth sound. So which of the following combination should be selected for better tuning of an LCR circuit for communication purpose? For which purpose? For communication purpose. Now I'll show you the solution for this. General solution. See, the general solution for this is so long. Okay, the solution itself is so long. Each and every option we have to calculate, you have to verify, we have to write the answer. Okay, it's a lot of headache. Therefore, instead of solving in this manner, I will tell you a simple shortcut trick, a simple tip. If you remember it, any question based on this, you can easily solve it. Now focus here. What we need better quality factor. What we need? Better quality factor. If we get better quality factor, then the tuning of this LCR circuit for communication purpose will be awesome. So better quality factor. So for better quality factor, we have some conditions. Now the conditions are resistance. Okay, resistance must be low, resistance must be lesser, then inductance must be higher. Just remember this one point. Okay, remember this point. Then capacitance must be lower. Now 2 quantities lower, 1 quantity is higher. Resistance should be less, this is inductance must be higher, then capacitance must be lower. Now check in the options, which among these options has resistance least? Now option number A, no. B, C. Okay, C has 15, so C has the least resistance. Now check which has the highest inductance. This is 1.5, 2.5, 3.5, 1.5. So again, in the option number 3, the inductance is highest. Then check which has the least capacitance. This is 35, this is 45, this is 30, and again 45. So among these 4, so 30 is least. See, all the 3 options satisfy this condition. So therefore, in just one stroke, you can answer it. Just 3 conditions we have to remember. Even in the 3 condition also, 2 quantities are lower symbol. 2 quantities has lower symbol. Only 1 quantity has higher symbol. What is that 1 quantity? Inductance must be high. Remaining resistance as well as capacitance must be low. That's all. Resistance must be low, inductance must be high, capacitance must be low. Very simple. And any question asked from this topic, asked from this model, easily within few seconds you can easily solve. Why? Why? Because we know the condition. This is the condition, this is the trick, tip, or whatever you can say. So hopefully you will like this video. Yes, if you like this video, please hit the like button, subscribe this small beautiful YouTube channel, share with your friends, as well as hit the like button. Okay, so stay tuned. I'm uploading still more amazing content for you guys from physics, chemistry, mathematics, biology, all the subjects in a single channel. Okay, so till then, bye bye, see you.